All right, so in this video, we're going to be looking at how to solve a system of equations using the substitution method, okay? And an important thing to note is we have to be sure to find the value of x and y. So whenever we have a system, we're looking for the point of intersection. So we're looking for the x value and the y value. What's convenient about this problem is we're already told that y is equal to -2. So we really only have one piece of information we're trying to find. Now, with systems of equations, we can't solve an equation that has two unknowns, okay? So in the equation 4x minus 3y equals 18, I can't figure out what x is because I also have y in there. And I can't figure out what y is because I also have x. So I just want to have one variable. And we could conveniently only have one variable because we're told that y is equal to -2. So I'm going to go right ahead and I'm going to replace y with -2 because I already know what y is. I'm not trying to find it. And then we're going to solve this equation right here for x. So -3 times -2 is going to be a +6. I want to get x alone, so I'm going to subtract 6 from both sides. This cancels. I'm left with 4x equals 12. Go over here. I'm going to divide both sides by 4. And I'm left with x is equal to 3. And so finally, I'm going to write 3 right here. And this is the point of intersection. So had you have graphed this line, y equals -2, which would be a horizontal line, and had we have graphed this line in our y equals mx plus b form, we would find out that 3, -2 is the point where those lines intersect. All right, so in this problem, we're being asked to solve the system of equations, once again, using the substitution method. So this problem is similar to the previous one, but it's a little bit less friendly because we're not given a value for y, right? Like previously, I knew y was -2. I went right ahead. I just plugged -2 into this equation. This time, I'm given an expression for y, okay? This expression is helpful because, as I said before, we can't solve an equation that has two variables in it. But this expression is telling me I could rewrite y as -5x plus 13. And that way I wouldn't be writing the equation in terms of two variables anymore. Okay? So I'm going to rewrite 4x minus 2y equals 16. And I'm going to put this in parentheses to make sure that I distribute properly. Okay? Parentheses aren't coming out the best. And I'm going to replace y with that. So I'm rewriting my 4x. I'm rewriting my -2. And instead of y, I'm going to have -5x plus 13. And this is going to equal to 16. And now that my equation is just in terms of one variable, I can solve for x. So I'm going to distribute this -2. -2 times -5x is positive 10x. -2 times 13 is going to be a -26. I'm going to recopy this for x and put a plus because it's positive. This is going to equal 16. I have like terms on the same side of the equation, so I'm going to combine those. 4x and 10x is going to give me 14x minus 26, and that's going to equal to 16. Okay, I want to get x completely by itself, so I'm going to move this 26 by doing the inverse operation. I'm adding 26. This will cancel. I'm left with 14x, and then 16 plus 26 is 42. My final step, I'm going to divide by 14 so that x is fully alone. This will cancel. 42 divided by 14. I'm left with x is 3. Be careful, don't stop here, because remember, our answer has to be a coordinate, x comma y. So I got to go back and find my y coordinate. You can pick either equation. I'm going to pick this one because it looks easier for me to answer it, okay? Because here, y is already by itself. It's going to be easier to get my answer. So I'm going to go ahead. I'm going to do y is equal to negative 5x plus 13. I'm going to replace the x with the 3. Okay. Negative 5 times 3 is negative 15. Negative 15 plus 13 is negative 2. So now I've found my x coordinate. I've found my y coordinate. So I could finally answer where these lines would intersect. And these lines would intersect at the point 3 comma negative 2. So for this final example, okay, again, we're solving our system using substitution. But our problem looks a little bit differently here, okay? In our previous examples, we had y alone in one example, and then the other example in standard form. Same thing over here, y was alone, and our other equation was in standard form. But here, y is alone for both equations. So our form of substituting is a little bit different, okay? The way I want you to think about substituting here is that y is equal to 2x minus 10, okay? And y is also equal to 4x minus 8, okay? Y is equal to two different things, okay? But that must mean these two different things have the same overall value because they're both equal to y, okay? Let me say that again a little bit differently. If I knew x was equal to 4, let's say, and I knew that x was equal to y, right? If I knew x was 4, and I knew x was the same as y, I could then derive the idea that y must be equal to 4, right? Because if x has to be 4 and x has to be the same as y, then y must be the same as 4. Okay? So the same thing, I was just making up a value over there, but the same idea has to hold over here. If y is equal to 2x minus 10 and y is equal to 4x minus 8, then the 2x minus 10 must be equal to the 4x minus 8. Okay? So we're going to solve this equation. And once again, remember, we're trying to solve for x and y. So at this moment, we have variables on both sides of the equation, okay? And I like to move my variable from the right-hand side to the left-hand side. So I'm going to subtract 4x on both sides of the equation. These will cancel. 2x minus 4x is a negative 2x. Minus 10 is going to equal negative 8. I'm trying to get my x fully alone. So I got to move the 10 by doing the inverse operation. Opposite of negative 10 is adding 10. These will cancel. So now I get negative 10 is equal to 2. And to get x fully alone, I'm going to divide by negative 2 on both sides. This will cancel. And x is negative 1. Okay. Remember, again, I need to find both x and y. So now I need to substitute my value of negative 1 in for x so that I could actually find y. In both equations, y is alone, so it's just going to be an easy plug-in. There's no solving. You could pick either equation that you like, okay? So I'm just going to pick the top one. You could pick the bottom. It doesn't make a difference. So y is equal to 2x minus 10. And I now know that x is negative 1, so I'm going to replace x with negative 1. 2 times negative 1 is negative 2 minus 10. And negative 2 minus 10 is negative 12. Okay? Now that I've found both x and y, I could write the coordinate. Okay? And that's the point where this top line, if graphed, and this bottom line, if graphed, would intersect or cross.